including our nice people who donated their time to teach the hands-on labs. John Sudaris, who runs the San Diego user group, who came up here today just for you guys and has been an organizer. Yay! Thank you, John. He's put a lot of time and effort into this over the last couple of months. Intel has been amazing, of course, particularly Sujata, Michelle, sorry, I'm saying that the French way. Michelle, Lindsay, the team from Intel has been incredible. So thank you all for volunteering your time. Thank you. Today and for the last 2 months. And okay, tell me when you're ready. You ready? All right, so now I'm gonna ask everybody back there to keep your voices down because now we're at the important part and I don't want Sujata to have to yell. So, so I'm gonna hand it over to Sujata and when you're ready to go, we will start the timer.
Hi everyone, I'm Sujata Tibrewala, Community Development Manager for Networking at Intel. If you are curious about what my role is, come back to me, I'll clarify. Because I do realize it's a non-standard role. So, yeah, a quiz later on this. So who here cares about networking? Oh, I see quite a few hands. Okay. Yeah, you're conscientious enough because you're streaming, right? Now we're streaming, so networking is doing all of that. So who's familiar with this diagram, the network function virtualization? So on the left, you have the fixed function boxes, and on the right, you have the same network functions virtualized, and of course, they are orchestrated with OpenStack. That's why we're here, celebrating OpenStack birthday party. Now, why do we like virtualization? They give you scalability and agility. But if that's the case, why are we not moving to them? Why don't we like them? We have concerns about latency and performance, okay? So rest of my 3.5 minutes, I'll just talk about what we do in Intel to solve this problem. So, anybody heard about user space networking? Okay, there are a few people who have heard of it. So why is it important? So when the packet comes to your network interface card, that's the bottom green block here, it goes to your kernel space, and then it has to go to your networking application, which means there is a packet copy, there is a kernel interrupt which happens, so it slows down your networking application. So what do we do about that? How about we take the packet directly from the network interface card, directly to the user space? No packet copy, no interrupts, no context switches. Anybody heard of DPDK? Okay, Data Plane Development Kit. That's what it does. Simple. So no interrupts, removes data copy. And then because the network stack is in the user space, it can be streamlined and optimized. In kernel space to do any change, it's a nightmare. Another optimization. Anybody familiar with L1, L2, L3 caches? Sure, everyone is, right? So when you do a packet lookup, oh, sorry. Oh, I wanted to use it as a pointer. So when you do a lookup and you have a miss, so instead of 4 nanoseconds, you go to L3 cache and you have a 40 cycles lookup, which is not good. So what do? You do bulk packet processing. If you attended MJ's session, he talked about that, right? So that's one of the ways how DPDK uses a hardware construct to optimize the software packet processing. Now, Intel launched Skylake processors recently. How many have heard of that? Okay, good. So one of the things, or one of the architectural advances there is for multi-core processing. So when a packet wants to come from one core to the other in the Broadwell or the architectures before the Skylake, they had to go from, pass from one core to the other, so that would add to the latency. So follow the green line. That's the path the packet takes from the core 0 to core n. Whereas in the Skylake architecture, you have a mesh. So you have a direct path for the packet. So that's the architectural advance that has been done now. So since I had very little time, I just gave a few examples of how we are doing packet processing optimization. So how many have heard of FIDO? Okay, so FIDO is a software switch which was open sourced by Cisco last year. Yeah, we have Sylvia here. Yay. Yeah. So they optimized the software switch on the Skylake architecture, and guess what? They have broken the terabit barrier. Anybody knows about software switches and performance, they know what that means. Okay, so with that, I'm done.
Hi, I'm Sylvia Spiva. I'm with Cisco DevNet, and I don't have slides. I have a website for you, and I'm going to tell you a little bit about what Cisco DevNet is. First of all, a shout out to my fellow Cisco teammates. Anyone from Cisco here? Raise your hand. All right, welcome. Anyone specifically from Cisco Cloud? No? Oh, very nice. Okay, great. So before I joined Cisco DevNet, I was a social media manager for Cisco Cloud, and that's where I met many of you folks from OpenStack, and I know that's a fun bunch, and I really appreciate you having us here today. But I'm with DevNet now, and many of you have the brand new DevNet shirts. Who was lucky enough to get a shirt today in their size? Okay, great. Excellent. So if I could get you to go to developer.cisco.com and check out what we have there. What is developer.cisco.com? It's the home website for DevNet. And if you've been to Cisco Live, or if you've been following what our new leadership has been talking about, it's really about taking Cisco from just a hardware company into software, and we need to have programmability into everything that we do. So when you go to our website, when you go to DevNet, we should have the APIs and the training material and the conversations we'd love you to be a part of for cloud, collaboration, enterprise networking, security. It should all be there. And if it's not, if there's anything else that you'd like to see, please let us know, because we're still a pretty new team and we're growing that community. So for those of you who got your shirts, that's awesome. If you'd like a shirt, go ahead and register. You can look up cs.co/7bday and register, let everyone know you were here today. And please also follow us on Twitter at Cisco DevNet. Again, we're very new and we want to grow this community. We want you to be part of it. Thank you so much.
Anyway, okay. The talk today is about why should you run Kubernetes on OpenStack. This is some technical insights from the VMware Integrated OpenStack team. Needless to say, I work in the VMware Integrated OpenStack team at VMware, of course. Let's cut to the chase. So why would you choose OpenStack to run Kubernetes? Why wouldn't you, honestly? It's been 7 years, and we have a wonderful community that we have built here. Kudos to all. Congrats, and clap your hands. I can waste 5 seconds on that. Anyway. In OpenStack, seriously, in OpenStack, you have everything that you need to build. Your production-grade Kubernetes cluster. Let's see why. Okay, that's not working. Okay. Is it serverless? No, right? Oh yeah. So why should you choose OpenStack to run Kubernetes? Let's see why. Reason number 1: easier deployment. Actually, it says reason number 4 on the slide, but why should George Lucas have all the fun, right? So easier deployment. There are tons of tools available out there to deploy Kubernetes on OpenStack. You could just do a Google search and be sure to search for Kubernetes on OpenStack, because if you do the other way around, there are so many other tools too. So there are tons of tools to deploy Kubernetes on OpenStack. You could use some of the native tools to deploy, or you could easily build a custom installer. You could hack it up. It's pretty easy to do that. And reason number 2, the control plane flexibility. If you are building a production-grade Kubernetes cluster, then there are a lot of chances that you need it to be highly available and highly scalable, right? And with OpenStack, you could leverage a lot of OpenStack services to build this architecture to pull this off. It's very easy to do that by using OpenStack. And reason number 3, and this is what will take most of the time, is that the cloud provider interface that's available in Kubernetes for OpenStack. So why do you need a cloud provider interface? The idea is that you don't just consume the underlying cloud for its capacity, but you consume the underlying cloud, some of its services, to run your container workloads in Kubernetes. So this is really important. Often, like when you're looking at the options to deploy Kubernetes on a specific cloud, this is what should be the number 1 in your mind. And fortunately for OpenStack, we have a cloud provider, and that just works. Honestly, it's a true story. It really works. The first time I deployed, I was not very hopeful, but it turned out that all the services that is provided by the cloud provider interface actually works. So what's the deal with the cloud providers? Actually, I wanted to say this with my Seinfeld imitation, but I'm too nervous today to actually do that. I'll probably in the next meetup, it'll save some embarrassment. So one of the first reasons is like external load balancers. So if you have services in your deployment, like front-end services or some API gateways, they may request a load balancer from the underlying cloud. And Kubernetes cloud provider for OpenStack will take care of actually creating that load balancer by talking to Neutron. You know how complex it is to create a load balancer in OpenStack, right? You need to create a load balancer, you need to create a listener, you need to create a pool. So all this is taken care by the OpenStack cloud provider in Kubernetes, and it'll give you a service IP. It'll actually give you an externally routable IP to your pod. So this is all taken care by the cloud provider. So that's really awesome. You should really learn about it. It is something that works out of box when you deploy Kubernetes on OpenStack. The next is persistent volumes. So I'm sure that if you're deploying any cloud-native applications, you will have stateful services, right? And stateful services need persistent storage. And with the OpenStack cloud provider for Kubernetes, the OpenStack cloud provider for Kubernetes will take care of actually leveraging the Cinder volume service to create the Cinder volume and attach it on the node on which your pod is actually running. So this is super awesome. And the chances in the cloudy world, there's always a chance that your pod might go down, your node gets killed. In this case, Kubernetes will automatically bring back this pod on a new node, right? Just like they brought back Jon Snow and Game of Thrones. Any GOD fans? No? Come on, no GOD fans. Anyway, and in this case, the OpenStack cloud provider will make sure that this Cinder volume is detached and attached to the right node on which your pod is running. This is all might seem like something really impressive. It actually is. You should try this out. And few other awesome things. I think I have exactly 1 minute left. So you could leverage Keystone for your Kubernetes services, for authenticating to your Kubernetes API. You could even write a custom authorization plugin based on Keystone. There are tons of things that you could do with this possibility. And few things to watch out for. As you scale, right, you will be adding new Kubernetes nodes to your control plane. And one thing to remember is that all your Kubernetes worker nodes will now make API calls to OpenStack, and you need to be aware of that. So hopefully your OpenStack cloud is like highly available and runs on really bulletproof infrastructure. And lastly, Kubernetes plus OpenStack, it's a powerful combination to run your container workloads. Thank you.
Thank you.
All right, so my name is Billy Field with Trillium Data. And what we do is we provide OpenStack data protection, backup and recovery. And what I'm going to show you today is from the tenant space, what we provide from a resiliency perspective, okay? So the good thing about Trillium is from the tenant point of view, we've integrated seamlessly into Horizon. We also are up with a full REST API and CLI. But from a tenant space, looking at the protection and recovery schemes, from a Horizon perspective, you jump into the projects. We expose a brand new tab called Backups. And as a tenant, I can go ahead and identify my workloads, right? So my application workloads. In this scenario, I have a gold, silver, and bronze, and I've defined my recovery point objectives as a 4-hour, 12-hour, and 24-hour RPO. And what we do at Trillium is we get the whole entire application blueprint of the cloud, everything from the networking stack all the way down to the Cinder volumes configurations in DataStat. So Again, at the tenant space, what I can do is if I go and look at a service level agreement that I've defined, Silver, what you'll see here is I have a 3 VM workload that is comprised of my application set. And what I do is, here's my points in time of that, like I said, the cloud footprint of that protection scheme, okay? So each one of these points in time is a fully formed image that sits in QCOW2 format. And what that means for us at Trillium is we can instantly access it for any purpose at all, from a recovery standpoint, from a file and folder level recovery standpoint, okay? And when I dive into what these points in time look like, looking at the metadata point of view, we capture, again, everything from the network perspective, so the virtual NICs, the IP addresses. We go across the top there with security group capture. We go grab the VM flavors from Nova, the volume types, the networking, everything nuts to soup there within the cloud. And again, from the tenant space, now what we allow these self-service capabilities within the cloud. So if I spin up my virtual servers, I now have a methodology of protecting and recovering on demand as a tenant, okay? So once you define the workloads and you get everything under management, diving back into the workloads, I can then offer up the reverse of the backup, which is the recovery. And if I come back in and dive into the snapshots, we offer a couple different interactions. Number one is I can do a full-fledged in-place recovery, so I can take that cloud at that point in time, blueprint all the way down to storage, restore that back into production as if I didn't lose it at all. I also offer a one-click restore, which allows you to take volume configurations and volume types and overwrite just the volume structures back into production, preserving the VM UUID and all the context of the VM. I can do a selective restore, which maybe my restoration process has to do with not back in place, but maybe I want to put it into a different region or a different availability zone altogether with different parameters, different network, different volume types, different compute perspectives. So selective restore allows you to do that. And everything I talked about today is VM level, VM level, VM level, but we offer an instant mount option that allows you to take the virtual machines, mount just the volume structures to a file manager that we offer, and basically extracts all the volume types so I can peruse through a web-based front or SSHFS. I can use SCP to get volume structures, files, folders, and then copy that back into the source location or dedicated target location I want to provide. That's pretty much it. I mean, there's nothing really super bedazzling about backup and recovery, so we're the only one in the space that does it. And again, we're OpenStack tenant level backup and recovery, and I've got a minute left, so we're good on time. Thanks, guys.
Thank you.
Yeah.
Okay, thanks everyone. I'm going to talk about getting storage right, specifically for clouds. We are at a birthday party for OpenStack. There we go. So last year we hosted the 6th birthday party, had a great time. When you're done listening to all this talk, we can bust out the cupcakes and start partying down. So just to move through it pretty quickly, storage is a critical part of any cloud deployment. In my career, I've talked to hundreds of folks who've deployed OpenStack environments, and people who should have not failed have actually failed. And being kind of a storage nerd, I think a lot of the reasons why they've had trouble is because their storage system couldn't do what they needed to do. It couldn't deliver the performance. It couldn't meet the needs of the users. They had cost issues. You know, the users are really actually very, very important. Sometimes it's data loss, and ultimately, if you don't get this part right, you end up with a project failure, which nobody wants to see. And I think it's unfortunate when that happens for everybody. So key factors to consider when you're looking at storage, especially for cloud environments, is around performance. And performance is not just about how fast it can go. There's a lot of buzz in the storage industry about flash storage and can you get like 10 million IOPS in a single U appliance. That's actually nice to have, but you really want to think about latency as well. So when you're testing and evaluating storage, make sure you evaluate what latencies it can deliver. And more important than that, does it have additional capabilities? Can it meet all of the needs of your cloud? Because if you just get fast storage, it might be too expensive. You might need slow storage, multiple vendors, lots of trouble. Next is scale. How big is it going to get? A lot of OpenStack clouds, I think the last survey, I forget the exact numbers, but the majority of clouds are fairly small. It's relatively easy to solve those problems. If you do plan to get bigger, those are bigger problems to solve. And you really need to think about what happens when I get to my 100th rack. What am I going to do? What kind of solution do I have for that? The agility piece is also important because as you noodle through the technology, the people that operate this stuff at scale will tell you, depending on your solution, you might not be able to add a little bit of storage because there's pain. Maybe you need to add a whole bunch at the same time. Swift has this when it's rebuilding its rings. You have to be very mindful about what does it mean, how agile, can I bring in another class of service and so forth. The operations piece, we talk about day one, talk about day two in the industry. Operations, of course, is super, super critical. If you can't make it work, it doesn't matter. It doesn't matter how fast it goes. You could have a great, one of my cars is a Triumph. I don't know if people know about British cars. Fun car. I don't drive it because I'm afraid I'm going to get somewhere and have to walk home. It doesn't matter how fast it goes. You need to make sure it works. And then, of course, cost. Can you take advantage of the trends on media, take advantage of the trends on hardware? Intel is talking about their Skylake, the Pearly systems. They're unbelievably fast. You want to get that stuff into your critical environments as quickly as possible. How do you do that? How long is it going to take? So what if there is a system, this is vendor time, right? So what if there's a system that could deliver the performance and you could get sub-100 microsecond latencies on the workloads that need it, but you could also have large capacity nodes that are optimized for cost. On the scale side, it can grow to petabytes between mixed systems, mixed vendors, which is another major problem at scale. Is you used to buy Dell, and boss comes in and says, we're not buying Dell, we're buying HP now. How do you address that within the solution? And then that agility piece, to be able to automatically onboard new classes of service. How do you move data between the systems? The timer turned off. Between the systems, so that you know that this workload is always going to be in the right spot. Is it a migration? Is that a user problem? Amazon just now got that feature working. And then the operational piece. Is it simple to use? Is there someone going to stand behind you? How much does it cost to get it fixed? Are you relying on having a team of people who know how it works? Because when that team of people go get a better job somewhere else and you're left with this big box, what do you do with it? And then last, of course, is the cost. As we see major trends in the storage industry, we're seeing this shift away from bespoke systems developed and designed with custom bezels and lights and all this flashiness to commodity-based servers because they can do that work now. So enter the Datera solution. It's built from the ground up. It's designed for cloud deployments. We're built on a scale-out architecture, for example. We continually optimize the infrastructure based on the needs of the workloads. We can transparently handle different types of media. So the Flash Memory Summit that's coming up in a couple weeks, we're in 2 keynotes from 2 major competitive vendors because they see our technology as enabling their newest generation. But we can also deliver high-capacity nodes and hybrid for the mixed workloads. So policy-based management is critical and seamless integration with OpenStack, VMware, containers, and one code base. Thank you. Oh, thank you.
Thank you, Bill.
Okay. Hi, everyone. My name is Farouk Khan. I'm really happy to be here to be able to talk to you. Although how I got here is a bit of a random, funny story. About 10 minutes, 20 minutes ago, I was just minding my own business. I was across the street in the park trying to get a suntan. And this guy comes running up to me and says, hey, I will give you $5 and some cupcakes if you run across the street with me and do a presentation on OpenStack. So before I could even say open what, he threw me in the back of a van, drove me over here, and here I am. So while I am here, I thought I might as well talk to you and give you some Ceph architectural goodies that I've learned from my time talking to partners, talking to various customers as well. Stay tuned, because at the very end, I'll also tell you how you can win a home that is also part of the Rackspace raffle. That's right, I said a home. So what the heck is Ceph? Ceph is a software-defined storage platform that is fantastically scalable and can back Nova, Cinder, Swift, Glance, and even Keystone. And it's rising to popularity very much so. Now, how many networks are recommended to use for Ceph? 2 of them. Why? Because on the front end, you need one for reads and writes. On the back end, where Ceph is particularly chatty, you also need one to be able to handle things such as node additions, replication, heartbeat, and also, if a node fails, for Ceph to be able to rebalance. So all of that takes a lot of CPU, a lot of I/O. It's very important to be able to separate out your networks in order to mitigate that from happening. Go. How many nodes should I actually start with? Good question. So rather than have that happen, 5 is generally where I see a lot of customers, a lot of partners go with. That's a good baseline, and there are many reasons for that. which I'm happy to go through after this, because I don't have very long to talk. Generally, the themes are around performance, they're around scalability, and also redundancy within the Ceph cluster. So bear those in mind. And what about the node configuration? Well, there's a few things to consider there. Firstly, Ceph is very write intensive, so you want to make sure that you use SSDs and the write intensive SSD models of that vendor. Intel, Samsung, many vendors have some great ones. Pick the ones that are right for you. And when it comes to then matching that to a good OSD and journal ratio, you want to say about 1 journal to about 4 to 5 OSDs. That's a good production start, and then scaling from there. Failure domains is another thing to think about in terms of physical redundancy. So this is whereby taking a physical node out of the cluster and putting that in a separate rack, giving yourself another level of availability, as long as you ensure that you size the top of rack switches correctly to give you enough cabinet to cabinet throughput. And the final thing on there is fast NICs. So what does that actually mean? Well, it does not mean using 1 gig networking in production. You deserve a slap for that, Robin. That is a terrible question. Nobody likes you, and Batman should be slapping you. Now, if your customers ask you that, do not slap your customers. I am not condoning violence by this slide. I'm merely saying to you, tell them to use 10 gig. 10 gig networking inside your environment for a Ceph cluster is where you should begin. As more options become available for 25, 50 gig NICs, as they become more cost effective, then you can scale up accordingly and benefit from that too. What about the actual storage? So how much storage do you need? Think about that by the amount of replicas you have. If you have 3 replicas, or even 2, then that's how many times over you need to times your storage. So if I need 10 gigs of storage, usable, I actually need 3 times that amount if I have 3 replicas to give me the 30 inside my cluster. So bear that in mind as you're going through and sizing your environment. So finally, let's look at the actual 2 types of storage pool in Ceph. One is replicated. We've been talking about that throughout. The other is erasure coded. So the replicated side, as you can see, very durable, very easy to recover from. Erasure coding in comparison, still durable, not maybe as much, but certainly more cost effective. What you have to remember is to balance that cost effectiveness with what your users actually want. And if you have a high I/O cluster, for example, erasure coding may not be the best choice for you. Last few things. So as you know, prizes to be won still in the raffle. There's also one at the Rackspace table, like I said, which is a home. Now, for those of you getting your hopes up that it was an actual home, I'm sorry, we live in San Jose and that's not happening. So this is a Google home. Just go to that table and you'll be able to do that. Last question. Where are the cupcakes? Thank you very much. Happy birthday, OpenStack.
Thank you. Jim from Randus.
So consuming clouds and cake, what is this guy going to talk about for 5 minutes or less?
Thank you, sir.
Hopefully make some sense here. I think we're really thinking about the way clouds are being consumed and used by practitioners differently and moving toward this consume model. So if we think from left to right, in the old world, even with enterprise applications before cloud, it was always thought of it as this big, huge, heavy stack. You start with the top, you go to the bottom, you have all the applications, all the different systems. Once you get it working, you don't touch it for 3 years. You do it again, you do it again, you do it again, and every time it takes forever. Even with cloud moving into this world, whether people were doing it with distributions or doing it yourself through the different layers, it ended up often still being a very big, heavy lift for companies taking that on and then operating it. So getting it going, and then waiting for that next upgrade. OpenStack was also fairly cumbersome to move from one version to the next. So that didn't really help either. So it was still fairly similar, still a heavy lift. Meanwhile, Amazon came along and took the public cloud by storm and really offered a different model, a black box model. And when you think of that, it's real simple from a black box standpoint. You don't see what's going on in those big buildings and behind the scenes. If you open the door and go in there, yeah, there are a bunch of people running around fixing hardware, putting in new hardware and so forth. But from the software standpoint, It's all done with CI/CD and very rapid change on a regular basis, hundreds of changes every day or every night. And that's where we really see things moving with what's going on in that lower part of the stack, and in fact, what we've been doing for quite some time in building up to the product that we've released recently. So bringing all these services together with OpenStack, which we've had for quite some time, Kubernetes more recently, rich SDN, storage as well, Linux, but being able to have that in a CI/CD consumption model drastically changes how the cloud can be operated and simplifies it, particularly for day 2 operations. So as we do that, we then offer a managed open cloud experience around the whole thing. So it's managed because it's turnkey and it's continuously delivered. That consumption as an operator then can either be in little bits, very often, big chunks, not so often, and anything in between. And it's all based on open source standards, all the different technologies I'll talk about. And it's a full stack designed for that new consumption model, as opposed to the heavy lift build model, where it just stays the same for quite a period of time. And that's really our mission in life. So that is what Miranta's cloud platform does and what it's about. So not only is it OpenStack, but there's a lot more in there. So the cloud software in red in the middle, we have OpenStack, we've added Kubernetes, and for the rich SDN technology included, we have Open Contrail. Of course, there's OVS inside in OpenStack itself. And for Kubernetes, simple networking, there's Calico. And for the software-defined storage, there's Ceph. I've saved about 2 minutes of my talk because of the last presentation, so you know exactly what that is. But more importantly, there's also Drivetrain, which takes care of that entire lifecycle management. And then Stacklight is the operation support system that provides all the monitoring and telemetry that then allows you to drive high availability. So I want to show what that consumption model looks like in action. If we take that, in the top left, Mirantis is creating our code, and instead of putting it out every 2 years like the foundation and like we've formerly done, so foundation puts theirs out, we would hurry up and put ours out as fast as we could, ideally in a month or 2, maybe a little bit longer. We're continually putting out code. We're putting out code as often as every 2 weeks. That could be a lot of code, could be a little bit of code, in some cases maybe no code because we're doing internal changes on things, but it's going out into an external repository in the form of artifacts. So then the way that that's consumed is on premises, the customer has Drivetrain, and that Drivetrain is a full pipeline based on open source technology, often the same tools that people are using up at the PaaS or application platform level. So we can use that same methodology, that same technology for cloud consumption and innovation down in the cloud itself. So as we take a config change or a code change, it's coming through Garrett, through Git, through Jenkins. The entire cloud infrastructure itself is modeled in reclass, and then Salt is what's pushing it into the cloud. I'm done.
So I'm here to tell you about this project, DragonFlow. So it's a network, a software-defined network project. So I want to point out it's for virtual machines and containers. Can you hear me? Virtual machines and containers. It's not new. It's been around since Kilo. So it's full-featured, 2 years, over 2 years. And it was built for scale, operability, extensibility. I don't have a visual for this, so I'll just explain extensibility quickly. So what that means is the software has a pipeline. Okay, so if you know networking, you know pipelines, tables that you can plug, you can create new tables. It has hooks so that you can call out to your function, and you can very easily add applications. So if you want to experiment, if you want to extend OpenStack to do something in networking, okay, anything in the control plane, very easy to do it with DragonFlow. And I'll go on to pluggable databases and the scale next. So in terms of scale, so we built for scale, and the way we did that was by moving the controller. So normally in networking, there's a controller that's programming the software switches, okay, or programming the TORs, but there's a controller that's programming the network. And the controller has all this state, and it knows all these things about virtual machines. It knows the networks, their IP addresses, it knows the security groups, the firewalls. All of this stuff has to go out and be programmed into software switches normally if you're doing overlays, and if not, you're programming TORs. And the controller is the bottleneck, almost always. So what we did was we focused on the database. And the database, basically database and pub sub, and you push out everything, and the controller is totally distributed. So if you're used to OpenStack with a network node, and the network node is there to do lots of functions like DHCP, it does your metadata, in some instances it does your layer 3, your source NAT. We remove all of that, and we do everything from the compute node, totally distributed. Now I'm going to talk about pluggability of the database for a second. Why is it important to have a pluggable database? Let's say you have a Kubernetes deployment, and Kubernetes using etcd, and you don't want to use some other database. Here I'm using Redis. You might want to use etcd. We have an etcd backend, and so you could use the same technology for both of your deployments. And of course, this can do networking for both Kubernetes and for OpenStack. So in this case, what I want to show here is that we put Redis in the back end, and this is a baseline test where we had 32 servers, and we ran a test. We launched an OpenStack configuration, ran it, and then we ran the same test with 4,000 controllers. So we didn't have enough hardware to do 4,000 compute nodes. We ran 130 controllers on each compute node. This is a test of the control plane, so basically you can see there are 4,000 controllers up top, 130 per node. The 130 are all talking to the same Open vSwitch, the software switch, but each is configuring a different bridge, okay? And so we ran the same OpenStack, the same OpenStack script populating ports, essentially virtual machines, and we measure, and the results are here. Basically, on the left in blue, so there are 3 scenarios that we run. In blue, you can see the performance, the runtime to set up OpenStack with our configuration when we had 30 nodes. And then when we have 4,000, that's on the right, so just a slight increase. So basically, because of the distributed nature of the architecture, and because everything is basically being pushed by the database, Redis, and Redis has plenty of performance with just 5 nodes, there's no impact whatsoever. And all the controllers get the same information, and they install the flows, and they get the topology ready for you. So lessons learned. So DragonFlow can scale and maintain the same performance. Neutron instead needs to improve. The Neutron script just takes a long time. If you fork Neutron, then you can go faster, but Neutron the API needs to go faster. We can scale, it's production ready. We can go to thousands of nodes the way the Kubernetes community tests with 1,000 nodes as a minimum. This should become standard for us as well. And Redis does great, millions of notifications. And finally, please just check us out. Good? Thank you all.
So I'm going to talk about OpenStack and containers, the same topic that I think everybody's been talking about. The last OpenStack summit was really the last container summit, right? Isn't that what it was? Happy birthday, OpenStack. There's a lot to talk about, actually. Where's the clicker? Means I can actually go fast, since I've already lost 15 seconds. So who am I? I'm the founder of and CTO of Cumulus Technologies. We're a cloud enablement company. We help you figure out what the right cloud is. And part of that is helping people understand where containers fit and where they don't fit. Containers really are a development tool. That's where it's come from. That's why we have all this need from our developer customers to actually implement and deploy containers. And really, they're a way of bundling an application. And we see that in how OpenStack wants to use containers and how application developers want to use containers. They're multi-platform. We find people like the ability to develop something on their laptop and then run it, the exact same thing in production, a very powerful tool. They're also very light. Often containers can start within seconds, whereas a virtual machine or even a physical machine might take minutes to launch. So a very powerful technology. A little bit of history sort of goes all the way back to when people started sharing systems and sort of separating the story. A lot of the people that were in my class were like, wait, I heard this already. I have to listen to it again. But we're really looking at a way of separating the process. So processes already have process level security. Containers take it to a whole new level by actually integrating not just the process itself, but all of the libraries and the resources that that one particular process needs to separate the capabilities out. And that's a really powerful component when looking at implementing an application environment. There are still some issues that some people have, specifically the fact that I'm still talking to one kernel. In a virtual machine, you get your own. In the container world, you get to share with others. So, sometimes you just have to be a good neighbor. But the real driver behind this, I think, is the development community. So the folks that are big DevOps proponents love developing things. They don't really like the ops part. They did it because they could and because, in a sense, it made their lives easier. Well, containers make their lives even easier because now their operations focuses just on the bundling of that container rather than the actual operations of the underlying infrastructure. So the resources really sort of come together much better. Really, containers and developers go together like cupcakes and OpenStack, I guess. But in the end, we still need to operate an infrastructure that supports that, and I think that's where these two pieces really start to come together. If we talk to some people, they would say we don't need OpenStack anymore. It's done. We can just do all of this with containers, but I think we all know better. The pieces really sort of do have other benefits. At the base level, we heard earlier that there are some really nice integrations even between some of the container operating environments like Kubernetes and an underlying OpenStack. I still need load balancing. I still need VPN. I still need DDoS protection. I still need storage. And accessing all these services is really one of the things that OpenStack has brought to bear as a very flexible, simple technology. It's something that we can all leverage. So there are really two parts to the story, though. Right, because there are containers running on OpenStack being able to leverage OpenStack, and there's also OpenStack running on containers. And we're seeing interesting use cases in both environments. In terms of OpenStack supporting containers, deploying Kubernetes on top, deploying Docker Swarm on top, deploying the next great thing on top from the container world, there are a number of technologies like Magnum, fun, that should have been Zune, and certainly, you can also just use VMs and another application like an Ansible tool or Chef or Salt, et cetera, to actually deploy containers on top of that environment. But OpenStack is another interesting use case for the container environment because OpenStack in and of itself is a distributed application. If the benefits of containers make sense for application developers, why would it not make sense for an OpenStack end user, an OpenStack application deployer? So really, we can look at a couple of technologies. Now I'm going backwards and forwards too much. The couple of technologies, the Kala project, and specifically now the Kala Kubernetes project for actually leveraging the container infrastructure, whether just containerizing the applications and deploying with Ansible, or actually using Kubernetes to deploy those containerized components and deploying an OpenStack service in that fashion. So, I think we see that containers are a core part of application development. OpenStack as an application is something that fits really well into that, and that's, I think, where it's all going. Thank you very much.
Thank you.